Okay, here's the bread and butter of the lesson. We're going to work with hexagons. But you're going to hear me use some terms and stuff that are going to help you. And one of those terms is going to be central angle. Now, remember on the other side, and in fact, we could almost go backwards here and do B first. It really doesn't matter. Remember, we talked about the radii. Remember, that would be your radius, and I don't want you to forget that, okay? Now, remember when we put two consecutive radii together, we make that isosceles triangle that will help us out. That isosceles triangle helps form, remember, the angle right here. That's a central angle. You always want to find the central angle first when you're doing regular polygons, especially if you don't know your apothem or your sides. So I'm going to find the central angle of a hexagon. So I'm going to take 360, because remember, all the way around a single point is like a circle. It's 360 degrees. And I would have basically 6 of these triangles. So I knew the central angle is just going to be 360 divided by 6. That's 60 degrees. So that would be 60 degrees. However, what does the apothem do to my central angle? That's right. It's going to bisect it. So really, x has to be 60 over 2. It's 30 degrees. So I'm going to have a 30-degree angle, and I wish I had room to put it there, but that would be 30 degrees. Now, I have to use that to help me find my apothem and side length, okay? And so I think it'll be a little bit easier if I redraw the diagram over here, okay? Off to the left here, because I think we can do it a little bit easier. All right, we're looking for P, and really Q is here because they're all the same length, so I'm going to put Q here. And we just found that to be 30 degrees. That's X. Now, one thing we didn't state, but it's true, is all the radii would have to be the same length. So I know this would be 8, which makes that side 8. And we talked about our apothem, which is the letter P here. It's going to bisect our base. Well, look at this. I have a 30, 60, 90 triangle. I'm going to ignore this side. I have the hypotenuse. I always go home to the short leg. Well, how do I go from the hypotenuse to the short leg? Remember, the hypotenuse is 2 times the short leg, so to go backwards, you divide. So I divide by 2, which gives me 4. This, for the letter P, is the long leg. You just go for root 3, because the short leg to the long leg, I multiply by root 3. But to get Q, I have to double 4. So Q is equal to 8. So I got equal to 8. P is 4 root 3. X is 30 degrees. Now, doing the same type of idea here, don't let things get too complicated. I want to solve for my radius here, okay, which is C. I know they're the same size. Notice they drew in the apothem up above, and it's 4. And D is still here. So let me redraw the diagram, because I really think this triangle, and by the way, I always call this triangle, the big one right here, the central angle triangle. Here's your 2 radii. I'm going to call it C. D is my side length. My apothem, because they go from the center to the midpoint of the other side, is 4. Now, once again, I need to know my central angle. I want to know A. That's your central angle. Well, central angle is still formed the same way. 360 divided by 6, it's 60 degrees. Well, that means this whole thing is 60 degrees. So A equals 60. But it bisects that, and look what I get again, a 30, 60, 90 triangle. And I can put the 30 over here on this side, which is fine. Now, this is my long leg. I want to get to the short leg, and the short leg, remember, is just half of the side, but that's okay. So I divide by root 3. I get 4 divided by root 3. Got to rationalize. 4 root 3 over 3. Now, so that's this segment right here. So D is twice that amount. That would be 8 root 3 over 3. Because 2 times 4 is 8. Now, to get to the radius, you just have to multiply it by 2. That's also 8 root 3 over 3. Now, I want to show you something. This side was 8. The radius was 8. What was the length of the whole side? 8. The reason why is on a hexagon, and only for a hexagon, each one of those congruent isosceles triangles is actually equilateral every single time. So it's kind of cool to do. Now, let's keep on going and try this with 2 very common regular polygons that we use. We have a square and we have an equilateral triangle. Now, what do we know about the central angle of a square? It's easy to find, but you should already know it. The central angle of a square would be 360 divided by 4. That's 90 degrees. Well, that's 90 degrees, but a square is also a rhombus, and a rhombus's diagonals are what? That's right, perpendicular. So we should have known that it was 90 degrees even if we didn't call it a central angle. But we still know that it's bisected by our apothem here. Well, what's half of 90? 45 degrees. This is great. So let's just plug in what we know. We know the measure of angle 4 is 90 degrees. Okay? We know that the measure of angle 1 ended up being, I'm going to mark it right here, 45 degrees. Now, notice since it was bisected, I said this one's 45. This is what type of triangle? If this is 45 degrees, what does the other acute angle have to be right away? That's right, 45 degrees too. These two end up being the same size. Well, then what's 3 going to be? Well, linear pair here, baby. That's right, linear pair. We get the measure of angle 3 is equal to 90 degrees. Not too difficult. Don't overthink it. Just make sure you get this down. We'll be all right. Okay? Now let's get the next one here. I have an equilateral triangle. And notice they drew in my central angle triangle again. I like the two radii together. Here's our side length. So I'm still going to have to find the central angle this time of the triangle. Well, there's 3 sides of a triangle, so it's 360 divided by 3 is 120 degrees. So the measure of angle 7, very easy to get, 120 degrees. All right? Now, however, what does the apothem do again to it? Bisects it. So the measure of angle 5 ends up being 120 divided by 2, which is 60 degrees. All right, if 5 is 6 degrees, what does that automatically make the measure of angle 6? 30 degrees. Now someone goes, Gregerson, how can you do that so fast? I'm still trying to write down the numbers. Why did you know the measure of angle 6 is 30 degrees right away? Because this is a right triangle. If the acute angle is 60, what's left for the other acute angle? 30. It's a 30, 60, 90. Okay? So don't forget that they go together. Okay? Now, we now can find the missing angles, but we have to be able to find the area. And this process is kind of easy. I'm going to ask you to do a couple different things. First of all, I do not expect you to draw a hexagon. That is really hard. But one thing I always expect you to draw is you draw the central angle triangle. Okay? And then you mark up the sides. Second, you calculate perimeter. Remember, that's a capital P that we use for that. Third, you do area. Okay? And so that's how you kind of go in order. So on this one, we're going to go and to put in the missing sides, I'm going to draw in. Now understand, I can do hexagons, but I'm not going to do the whole thing. I'm just going to first draw the triangle. Okay? So here's the radius. Okay? We're going to have a radius. We're going to draw in the side, and now use your imagination. Understand the polygon would be coming like something like this, but just ignore that for right now. We have our radius. We're going to have an apothem. Okay, what does the apothem do to our side? I want you guys to get in the habit. Okay, I'm going to draw an arrow so you remember where the central angle is. So we're going to do that. Now I'm going to label what else I know. I know the side length is 6. Okay, I said the second thing to do is calculate perimeter. Okay, so perimeter is pretty easy. I have 6 sides, n equals 6. My side is length 6, so I get 6 times 6, which is 36. So it would be 36 centimeters. So the perimeter would be 36 centimeters. So we got that down. However, I need to calculate area, but to do that I need to have my apothem. Well, to do that, you have to find the central angle. Okay? So the central angle, remember, again, is 360 divided by 6. It's 60 degrees. But what happens to the central angle? What does the apothem do to it? It bisects it. Very good. So again, I get this 30-degree angle. Oh, look what your apothem does. Bisects this side, which is 3. Oh, look. A 30, 60, 90 triangle with the short leg. The long leg's the apothem. How do I go from the short to the long? We multiply because we're going from smaller to larger, and we multiply by root 3. That's 3 root 3. So that's how we get that. So now I have the apothem, now I have the perimeter, now I can calculate area. You can still see that there. Very good. Area equals apothem times perimeter over 2. Perimeter, we use a capital P on this one, all right? The apothem is 3 root 3, I'm going to keep that in parentheses, times 36 all over 2. Here's the easy way of doing it. 36 divided by 2 is 18. 18 times 3 is 54. I get 54 root 3 square centimeters. This is a type of problem you must know how to do. Okay? Regular hexagons are big. We need to make sure we can do those. Now the next one, and remember this is our central angle triangle, so don't forget to draw that, is for a regular triangle. And now there are faster ways for triangles sometimes than this one, but this is one that we want to do in practice. Now, normally I'm saying just draw the central angle triangle, but I want to show you the difference between the two, so I'm going to actually draw the equilateral triangle. And if you're doing this on your own, draw it big, okay? Here's my center. I'm going to draw in my central angle triangle by drawing in my 2 radii, so there's my 2 radii. They told me my apothem was 4, so A equals 4. Now, I have to find the side length so I can find perimeter. But to do that first, I have to know the central angle. And remember, the central angle is the big one, all right? So let's go central angle equals 360 divided by 6. That's 60 degrees. But what does the apothem do to it? That's right, it bisects it. Oops, I just did that by 6. Please, guys, I'm not even at school and I'm messing up. Divide by 3. That should be 120. Did anyone see my bad math error? How many sides does a triangle have? 3. That's right. So it'd be 120. 120. All right. Hopefully I was just making sure. I wish I was, you know, suave enough, you know, and crafty enough to sit there and say, oh, I meant to do that. I just want to make sure you're paying attention. Except for you all know me too well. I would do that no matter what anyway. So, pardon me. Forgive me for that. Let's go ahead and get the fact that's 120. My apothem, however, still bisects it. So I know that these two are both 60-degree angles, okay? Which means this would have to be a 30-degree angle of a 30, 60, 90, which is kind of nice right now because that's my short leg. And I need to get my long leg because please don't forget also that your apothem bisects this side, so that can help me figure out my whole side length. So from short leg to long leg, I get 4 times the square root of 3, which means that one's 4 times the square root of 3. Oh look, your side length is 8 root 3. So perimeter is 3 sides that are 8 root 3. So that's 24 root 3. And that would be in inches if we were doing perimeter, right? But we're doing area. Area is apothem times perimeter over 2. My apothem is 4. My perimeter is 24 root 3 all over 2. 4 times 24, that gives me 96 divided by 2. Be 48 root 3 square inches. And there's your area formula. Make sure you line everything up just like before. All right, we have one more page and a few more examples, and then we'll be done.